In the previous video, we showed how the Caesar cipher is rather insecure and how it only takes 26 times, actually 25, at the max to decrypt it if it's a Caesar cipher. There are other ciphers, there are tons of other ciphers, and many that are, well, they're almost all better. So we're going to demonstrate that even some of the better ones that might sound secure to you and are definitely better than Caesar still aren't very good. So here's a simple cipher program. Right now, this is acting just like a Caesar cipher, but we can change it. So let's look at what we have here. At the start, I have my variables defined, or at least most of them. I have alphabet, which is just a string of the alphabet A through Z with the space, just like in the previous program. I have a variable called key, which is all the letters of the alphabet again with the space at the end. Notice I didn't start with A and I didn't end with Z. They're all off by 1, like a Caesar shift of 1, hopefully you noticed. You also might see this sometimes called a ROT cipher, an ROT cipher. It's basically short for rotate. So rotate of 1 would be a Caesar shift of 1. A rotate of 13, which is what I often see it mentioned online by, would be a Caesar shift of 13. Same thing. Why are there two terms? I don't know. Then we have the clear text, which is the original message before it's been encrypted. In the previous one, I did an input command so the user could put it in, but that's not really the point of what I'm doing right now, so I just figured we'll just use a default and it'll be fine. When zombies arrive, quickly fax Judge Pat. So this is sort of like the old saying, quick brown fox jumps over the lazy dog. Basically what it is it has every letter in the alphabet in there. It's called a pangram, and there are others, but this is the one that I like. I've got two functions defined here, one to encrypt and one to decrypt. So let's talk about what they do. So the encrypt function has a variable called index vowels, alphabet.index, char.lower for char in clear text. So what does that mean? So inside of the alphabet string, it's looking for the index value of the lowercase character of a character in the clear text. So basically what it's going to do is it's going to see this W, and it's going to look for that W in here. Now there is no capital W, but it is being converted to lower, so it's going to find this lowercase version of it. Now what's going to happen is it's going to return the key index for the index key in index vowels. So what does that mean? So this is like spot, like, let's see, 26, 25, 24, 23. So 23, it's going to then kick back that same place value from the key instead. So if it's 23 from alphabet, it's going to kick out 23 from the key, so an X. And it's going to join that with what's going to become the encrypted message. So it's going to do this for each letter. So W, then the H, then the E, and it's going to do that for each letter throughout this string. Looking for whatever place value the letter is in this, looking for that same place value in here, and replacing it with whatever letter happens to be there instead. That's going to be how it encrypts it. For decrypting, it's doing the same thing. It's looking for the place value of that letter in the key, and instead replacing it with whatever letter is in that same index spots in the alphabet. And I don't really feel like we've talked that much about index values and some of that stuff, or at least we haven't lately, but it's okay. Hopefully this makes sense to you. So that's what it's going to do. But keep in mind, we have just defined these right now. We haven't actually run them, so it's not doing this yet here. It's just learning how to do it. We're going to print the original message, the clear text, so it's going to print when zombies arrive. Then it's going to finally do the encrypt method, so all of that hunting for each letter and finding out whatever the key value is. And it's going to save that into Cipher, which it is then going to print. Here, on the next line, it's going to then decrypt it to make sure that it did everything right. And the way it's going to decrypt is going to do that same thing that it did here, but in reverse. But instead of using the cipher text, it's going to instead use the string that we've now stored here in Cipher. I just told it to print the function here, and I didn't tell it to print the function here, and the reason why is because if I told it to print the function here, it wouldn't have this string saved to the decryption method. If I didn't care about decryption, then I could have just told it to encrypt here instead, and that would have been fine. I didn't have to do that. But because I wanted to decrypt, I needed a string saved for when I'm calling the decrypt function. So let's try it. Whoa, it is not happy. Why? Line 18, encrypt, cipher, encrypt. This is fine. Alphabet.index for char in clear text. Clear text. Substring not found. Substring not found. Oh, huh. I know what it is. Okay. So we've got our strings here. And I've said when zombies arrive, quickly fax Judge Pat. And I've got a comma there, and I've got a period there. And there's no comma or period up here, and so it does not like that. So let's go ahead and put a comma here, and a period there, and a comma here, and a period there, and let's see if it works. Beautiful. So we've got our original message, and we've got our encrypted message. So right now, like I said, this is just a Caesar cipher, just a rotate by one, whatever you want to call it. But there are other methods we could use too. So we could use a keyword substitution cipher, which is basically where you choose a word, like, I don't know, zombie. And that becomes the start of the key. And then we just put in all the other letters afterwards. So I haven't used the A yet, so A goes in. I've used the B, because there's a B in zombie. So then C, A, B, C, D. E's already in zombie. F, G, H, I's already in there. J, K, K, L, M, nope, N's in there. N, O's already there. Q, R, S, T, U, V, W, X, Y, no Z. Ooh, we missed one. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. Q! I missed Q. There we go. Strings line up, so everything should be there. So now if we run this encryption, there we go. There it is with a keyword cipher of zombie. Now, there are some weaknesses to this, and you might already start seeing them here. Let's do a different word. Let's do one where most of the letters are towards the front of the word. Let's do Alice. Let's say that we're Alice and Bob, and so the keyword is actually going to be Alice. So we already have the A. We don't have a B, C. Oh, we have a C. B, C, D, E, F, G, H, I, J, K, L, M, N, O. Oh, we have the L. M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So do you see the problem here? So since Alice is all towards the front of the alphabet, as soon as we hit the L, all the rest are the same. So if we try to encrypt something with keyword Alice, not very great. When zombies arrive, quickly something pat. You might not know all the words, but it's already halfway decrypted for us. So keywords aren't always that great. Now that being said, there's no reason you could combine that with like a rot cipher or something too. So you know, maybe you do that, and then you put the Z in front and you push it all back by one. So that's going to be significantly better. Now it looks much more like gibberish. But even still, it's not necessarily that great of a cipher. It's not going to be very good. So I'm just going to grab something from the Gutenberg project. Let's go to book categories. Let's do horror. I often like to use Mary Shelley's Frankenstein, and I think that's what I'll use. Where's Mary Shelley? Whatever. I'll just search directly for it. Alright. Yeah, there's a gargantuan paragraph. Let's use that. No, let's not use something that gargantuan. Alright. So that's annoying. Let's see. Will word wrap fix that? I think it will. So view, active editor, soft wraps. There we go. That's not bad. Any special characters? No, that's lucky. So just commas, periods, no exclamation points, no quotes. Let's try it. Oh, that's annoying down here. So let's word wrap this too. Alright. Ooh, let's put a line break in there. Oh, hey, buddy. Soft wraps. So when we look here, even at this encrypted message, we can still look and see if we see any single letter words, and we do. We see an F. So this F is either an A or an I. And if we want to go ahead and try it, we could tell it to, so Cipher dot replace, let's say that all the F's are going to become I's, and then print Cipher. Oh, sorry, buddy. All right. Oh, let's put a space in here. Play. All right, and soft wraps. All right. So what else can we look for? So oops, it didn't fix it. Cipher equals cipher dot replace. That should be better. And then use the soft wraps. Let's see, is our I in there? Our I is in there. So we've decided that F is probably I, although F could be A. But let's see, what else could it be? So do we see any other giveaways? Ooh, there's an F right there towards the end. And we see this here as well. So by process of elimination and substituting things in there, we could try to start figuring it out. So maybe this is like an if, or an in, or an is, or something like that. So we could try another one where like M equals S. And we can see if that starts to make sense. So there's is. And maybe these are O's. Maybe this is so. We can start to try to see if it makes sense. So then maybe N equals O. And you just kind of keep doing this until you start to hopefully figure out what it might be. And of course, we could be going in the wrong direction, but you get the idea. Now, this isn't the best method. This is a method to crack things where you start to try to figure out what it is, but there are other methods as well.